Alright, we are live! Hello everyone and welcome to today's live stream, where I need to change the music volume by a little bit. But yes, today I'll be working on swarm stuff. So I've been wanting to do this for a while, you know, crowds and swarms, they're very popular effects in like movies and stuff like that. And I want to go and try it out. So, the plan is fairly simple. We're going to make a simple particle system, or hopefully simple particle system, that will have a ton of particles moving around, and then we will go and attach characters with varying crawling speeds in this case to the particles depending on how fast they're going. So, in theory, this should work pretty well. I went and did a little bit of work beforehand, got this model off of Mixamo with the animation, timed it out so that we know how far it's moving per second. So in this case, it's moving at 75 meters per second, and that's just going like that, which is good. So let's go and get the actual particle sim going. So in this case, I think I'll have a stage that's about this big. Faces, yeah, that should be good. Then we'll just go and make it like this. So this is going to be the surface that the creatures spawn in from, and they'll try to stay on these while trying to go towards a target object. In this case, it will be, yeah, just a sphere. Yeah, that'll be good. They'll try to make it to this goal, while more just keep spawning in and it'll spill over, and they just try to make it to there. So yeah, and the speeds will vary, and the most difficult part will be the self-collisions, of course, to make it so that they will actually, you know, clump up and not just, like, I don't know, freak out when they're colliding. But yes, here's this. Let's go and move this over to a collision collection. Let's go and move this out of here. Let's go and make a set collection. Yep, that works out just fine. Let me go and color these because my brain sees color before words. Go, and this one, yeah, that'll be fine. And then let's add in our GeoNodes object and get this all started. So let's go and make a nice simulation here. So let's add in a simulation zone. And we'll go and create some particles per frame so that we keep having more particles added every single frame. So that's pretty simple. We just use a points node. I'll set the radius to be maybe 1.5 to match our character's size. So if we do this, we can see, actually, alright, it's a radius, not a diameter. I keep forgetting about that. Then we'll join this into the fold every single frame, and we'll do that last so that it doesn't interfere with anything else. So we'll do this, we'll put this over to here, and we will probably need to add in substeps, but we'll save that for a little bit later. Okay. So first thing I'm going to do is use a relax points node. Now this is a custom node group that I made in my like everyday node group pack, which is up on Gumroad for free. But this is the internals. It just goes and makes it so that particles will see the nearest one to them and then try to move away. But we can see that there is a slight issue, which is that if they're in the exact same position, I won't actually move them, which that is actually planned behavior, so I'm not sure how I would actually fix that. But let's use the scene time frame in order to manipulate this, and we can see that, yes, that is working as intended. Let's use the radius to make sure that they move away from each other, and we can see that that part works. So, them moving away from each other is good, though we can make it a little more squishy. So let's go and do that. But yeah, now we have a ton of characters, in quotes, moving around so that they won't collide with each other. But now let's add in the self-collision. So let's do this. So we need a realized instances. Now let's get the SDF mesh, which again, this is from my node group setup. So I apologize that I'm using like custom node groups more, but to be honest, that's the only way that you can do this without spending an hour recreating it again and again and again every single time. But who knows, maybe one day we can have stuff like this in Blender by default. We can have this, and now they will not... Oh, wait. Let's correct the normals on there. So now they will not collide into there if the radius is actually put into there. There we go. We can see that that's working. Though maybe I should have the particles join in first so that... Yeah, no, that's actually a good idea. I would love to see how you do sub-steps. Yes, okay. Let's go and actually do the sub-steps. So, yeah, that's fine. Go and do this, and I guess I could put... Yeah, that might actually be a good idea. Okay. So, first thing that I'm going to do to make sub-steps easier on myself is to put the entire simulation into a node group. So this will be our simulation group, and then outside, like once we get like closures and all that, the kind of function-ish nodes in Blender, this will be easier. But for the time, well, actually no, it would be about the same. We'll just put everything in a node group, and this will be our crowd sim, or crowd or swarm. I'll do swarm, because crowds will be just a molecule different. But we have that, and all that's fine. So we have our particles be joined into the fold here. Which let's go and put that into a nice little frame. I can collapse that, because that's just to avoid some of those things. Self-collisions are just fine. The actual collision is right here, which I will need to store the normal data, and yeah, the velocity data. But yeah, we'll get to that in a little bit, but this is just the collisions. Do that. So again, collisions. There we go. So now let's add in the substeps. So for that, we use a repeat zone. Everyone loves the repeat zone. We go and do this. We go and do that. Then we go and do this. And boom, you have substeps. But we need to make it so that the substeps get affected by delta time. I'm still not sure if... Oh, I lost my train of thought. Oh no, yeah, we will need delta time, but the substeps, we might actually not fully need them yet, but I'll just put them in for, because it's a good example. Let's go and put in an input. We'll make this dt for delta time. There we go, and for the delta time, we just go and divide the delta time by the amount of iterations. So here, let's go and add in an integer. And put that there, put that there, put that there. And now, as we can see, this is a fully functional, well, you know, for the most part, fully functional substep system for particle sims and all that. Let's see. So now this is running at 2 times per frame. But, yeah. Okay. So do I just get the velocity going? Do we need velocity for this setup? I'm thinking yes. So what I'm going to do is use my velocity step node group again. This comes with my geometry node asset pack, free on Gumroad once again. And we do not want gravity because, as we can see here, we do not want our swarms to be doing that. Yeah, we have that, and oh, those are just levitating. Much fun. Now, I think I should move the new particles outside of the group because this is too many particles to be joining in every single time. But let's go and start instancing our monsters into the thing. So in this case, I'm going to... Actually, we just need the object, so I'll make this one character 0.75 meters per second because we will be switching between different speeds. Instance on points, let's just do that. But as whoa, that is the heck? Okay, that's a bit better. Oh, actually, wait, no. We're gonna need... No, this will need to be a collection. Yeah, because we'll need multiple armatures moving at different phases so that it doesn't look like they're all synced up. So separate children, pick instance. Crap. Let's, dang it. Here, this will be, 0.75 meshes. Put you into there so that we can have the meshes separate from the armatures so that that does not happen. There we go, so relative. Now we have a ton of our characters doing that. Which, actually, yeah, no, we do need gravity. We do need gravity, and we need a force to bind them to whatever surface is nearby. Yeah. Because right now they're just floating, so negative 9.81 meters per second. So that'll happen. But I don't want them falling off because that's not the best. So I guess we'll need to add in a force for the to make them go towards the collision mesh. So here I might need to just make another group for this part of the collision because this is wait, there we go. Because this is going to get ugly really fast if I don't keep it organized. So here will be the hits, so hit SDF, and then this will be the hit normal, because we'll need to use those. So we'll have that, let me change that to a vector. There we go. Now let's get you, put you into there. Again, just capturing it so that it doesn't have to recalculate, storing it for later, and all that fun stuff. So, yeah. Another thing that we need is to store a rotation attribute. So this will be actor rotation. And we'll make this a very nice quaternion. Now, could this be a vector? Yes. Would that probably be better? Maybe. But we're just going to run with that for the moment. So here we go. We'll put the rotation into there. And here, we will use the previous rotation. Actually, should I put that first? It might actually be... it's fine. Do a quaternion. And we'll mix that with a... Well, actually, no. Let's get a first rotation working. So we'll need an axis to rotation so that we can determine which way is up for all of our characters here and which way is forward. So forward, that one's pretty simple. We just use velocity, and that will be on the x-axis. And we can see... Problem number one is, oh, they are spinning a little bit too fast to new orientations, which we will change. But we'll also use the hit normal, which I really should stop capitalizing my variables. Now that I've, been doing a lot of GLSL, it's like, oh yeah, let's follow the normal conventions, but I'm so used to doing this in GeoNodes. But anyway, here we can see that the hit normal is now working with all this. There's too much, there's way too much space. Let's set this to be 0.5, because I want them to actually land on the surface. Oh, no, I understand now. Because the character's up here, right? So let's just go and make it so that the character's just, lower just enough so that it actually looks like they're on the surface. And we can see that we're already getting some functionality, but we just need to delay it by a bit. So we might need to go to level 2 of our node groups, which I highly dislike nesting a lot of the node groups, but it might be necessary in this case. It will be necessary at some point, but I'll delay that for as long as I can. Let's make this a quaternion, and then we will mix the rotations. There we go. So now, and I'm not using a delta time lerp, even though, oh no, I need to put that in my node group assets, a delta time lerp. There we go. But here we can see that it is... There we go. It's taking them a bit longer to switch between all that, but it needs to be even more. Because again, it's not using delta time. But are they actually Is their orientation wrong? Okay. So we're getting a good amount of the things in here, but we need to make it so that there's more iterations and less of that happening. There we go. That's more of what I wanted. There might be a few on top, there might be a few around, but that's like the main thing. Alright. That's that. Now let's go and add in more forces to all of this. So for the forces, we'll just have our gravity force and a force to our target object, which in this case is going to be our empty. We'll go and use a nice subtract node to subtract the current position to the empty. Let's set that to be relative. And we're going to go and normalize it so that we can set how much they want to go towards that direction. So in this case, it'll be, yeah, they'll have a force of 1 meter per second to try to go to the... We should, actually, I need to crank that up quite a bit. What? Oh, that's because the collision. Let's just close off the bottom part of this, or better yet, let's go and move this over to here, and this over to here, and this back, so that, you know, it'll be, yeah, they'll spill over, but they're still trying to move over there. But we can also see that the rotation was wrong, because apparently it's the Y. Wait. Oh. They're just facing the wrong way. Let's set this to be like 0.5 so that they rotate a bit quicker. Now I could just rotate the armature in order to make it go the way I want, which yeah, that's what I'm gonna do. 80. So now we can see that they're all facing the right way. They fall down, but they're still trying to make it to there. That's good. That is good. We're getting there. Just taking some time. So now I need to make it so that the animation actually repeats. So for that, I will use the non-linear animation editor. Put that down into an action, and... Oh, wait. I've got, Wait, how do you make this repeat again? Reversed, action... I haven't used this in a while. I haven't animated in a while, which I really should. Hold forward. Nope, 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 nope. Reversed. Cyclic strip time. Cycle the animation time with action start and end. No. Time, nope. If anyone in chat knows rule... Oh, repeat. There we go. Okay, it is working. But we're just going to need to copy the animation a few times so that it's not all synced up, and then we'll need to do the varying speeds. So this is just something with Blender that we need to keep in mind. We can't affect animations and offset the timing with geometry nodes, even though that would be extremely cool. We just can't do that at the moment. We just don't have access to all the data. So what we're going to have to do is copy our animations here out of that mode. And then we're just going to have to move this back a little bit. But here, even with 2, we can see that we're already getting quite a bit of variation. It would be nice to see how much they repeat. So I think 3 will be good. And if it starts to lag, which... it will, soon enough. Dang. Or, wait, I can just select hierarchy. There we go. Okay, it's not lagging yet, which I'm happy about, because we're gonna need like 15 million of these. And we'll just do that. So with 3, you can see that we're already getting quite a bit of, No, but I'm still seeing a lot of syncing between it all. Oh, wait, we're not picking the instance. That's why. Oh, separate children was off. Okay, so now we should see that we're getting a lot more variation. But yeah. We need to change a few things in order to make it fully work. Yeah, we'll need, I think 3 variants per speed is fine. And then we just need to have that. Because right now, I think what we're seeing right here should be the slowest speed that they can run at, because that is like deathly slow. So if we go into here, let's add in a lot of damping. Because they should not go to... Oh, they're bouncing! That should not be the case. We want the bounce to be like that, and the friction to be maybe like 0.2. No, bounce 0. Here we go. Yeah, but we can see that that's, you know, moving a little bit too easily. Maybe I just have one for fast mode and one for slow mode. So let's go and copy, duplicate collection. Is it lagging yet? Oh, it's actually not. I am happy about that. So let's go into our armature. So we'll make this, let's see, what's 75 times 4? That would be 1.5 into 3, so 3 meters per second. We'll have 3 meter per second variance, and I'll just the names, you know, as simple as possible. As simple as possible. Come on, buddy. But I do not want to have to rename all those, just the collections. This one will go at 3 meters per second, and then I can make it so that, oh, if it's like less than 3 meters per second, we'll switch to the slower variant. So here in the animation part, let's go and make sure that we select the correct one. There we go. So for here, we'll set the speed to be 4. And then this one to be 4. So that's the biggest thing, needing so many variations to compensate for that. So as we can see, nothing has changed because we have not set up the logic to switch between the different parts. Which, I forgot that this may be a bit of a pain, because we have the instance index, but right now that would not be per collection, that would be per object inside of the collection. So, yeah, that's gonna be a pain. Although maybe I can automate the process and make the variations using a sim. No, that's a dumb idea. We can just go and separate geometry depending on if the velocity named attribute. There we go. If the length of the velocity is less than 3 meters per second, or we'll do 2. So if the length, we'll do less than 2 meters per second, it will switch to the slow variant. Or yeah, if it's greater than, it will be the fast variant, and the other one will be the slow variant. So again, it is annoying that we have to do it this way until I figure out armature, or this will be AM, or AM, yeah. Just trying to make it a little easier to tell what's going on. We have that. So now we... Sorry, what's going on here? Why does it look like they're disappearing? Oh, that's why. Or is it... Oh, look, whoa. Wait, why is that happening? Why are they... Did I miss something here? Because, okay, it looks like I screwed something up in the animation tab. Playback. Oh, wait, no. No, that should have worked. Playback scale. Here, let me hide everything besides... Right there. Let's see how you're all doing. Oh, scale went... Yeah, okay. I need to set this to be 0.25 instead of 4, because it's scaling, not multiplying, or dividing. Multiplying, not dividing. Here. Okay, yep, that's brilliant. That's great. Let's just make sure that we have these in even-ish increments. So here I want this to be halved, and this one I want it to be like a third. So that we have, yeah, just enough variation, and that looks absolutely hilarious. Let's make a new collection for the, let's see, I guess mesh versions? Animation versions? Not sure. I'll just, yeah, mesh version should be fine. Now with that one, that's the original body, which we actually don't need anymore, so I could go and delete that entire part. And then in here, we have empty O1. Which is there. What is this empty doing? Oh, that was for, yeah, the original animation. Here we go. I actually think they're still moving a bit too slow. So I could turn it up by even more and it would be better. But we are seeing that it's starting to lag. Though it is a little weird how that's happening. Maybe just one speed would be good. So yeah, let's just do this. Just one speed. When they change speeds, it would snap instantly. But actually, wait, that's actually not too bad. Like, I could always put in a speed limiter. Or make it so that they're always going at this precise speed. Oh, wow, that's actually not terrible. Like, there's... they have absolutely no pathfinding whatsoever, so they're just gonna keep ramming their heads into the wall. Actually, yeah, how would I do pathfinding? Just have a grid and then a shortest path node. What happens if I put this right over here? Hey guys, you're not going the right way. It's right here. Oh, there we go. I mean, that part seems to be working okay. But that part is not. So I guess, So we don't need this part, because we're only going to use one speed, because that's what looks the best. So yeah, the hit position normal force. We might make it so that that'll be another force to just keep them in line, aligned with everything. Delta time is connected to there, that's good. And it's only the forces that absolutely need the delta time. And if, you know, in theory I were to disable the gravity, we'd see that we get that, some more of that swarm functionality. Oh, that almost works well. The only downside being that the collisions are a little bit iffy. But yeah, let's set it so that gravity is just less. Aw, dang, I do want them to, like, clump up like that. I still want them to be attached to... You know, I like that functionality to it. Okay, let's go over to the armatures and speed them up once again. Animation. Let's go and set this to be, yeah, a bit faster. So they're 5 times faster than the default, which is 0.75 meters per second. So the name here is just wrong. This would be, meshes. And this would be like 4 meter. What's 0.75 times 5? My brain can't. I do math for a living, and I cannot do the calculations in my head. Classic. But here we can see, yeah, that's going, but it looks like there's not enough variations with all that. Actually, wait a second. They're picking different ones, right? Looks like the rotations still need some work. Actually, let's get that delta time lerp in effect. So again, to do that, power... Oh, I forgot how this works. To do a 1 minus the factor. So this would be like 0.1. And then we need the delta time. Wait, does the delta time go on top or on the bottom? That would make it just so that it would, like, take a certain amount of time to... Actually, wait, I have the solution right inside the node group. Delta time, okay, is the exponent. Okay. Delta time is the exponent. So I did it right. Nice. So here would be that. And that's the factor. So in 1 second, it'll mix halfway to the new value. Although, we really, well, no, with substeps, we absolutely need it. Here we can see. I just don't want them to be able to spin too fast, because that would look weird. Oh, and I could try making it so that they share velocity. That could be a good idea. So here, with the relax points, I'm just going to go and copy this part right here, put it into there. So if I make them share or mix their velocities together, that will do that. Oh wait, I'm going to change my theme real quick. I changed it from to squared. I feel like both of them though. So we'll make them mix between the two, and then we'll just store the velocity vector right there. So with this, we'll now see that they're a lot more cohesive as a unit. Actually, wait a minute. Actually being very slow. Weird. I thought that would help, not hurt. And I do want to avoid stuff like that. So maybe I just need to guarantee that they'll go a certain distance. Which with this, you know, that's how you do it. It's just normalize, set it so that they'll always go like 2 meters per second. In this case, they will always go that fast. In this case, they will always move at this speed, no matter which direction. They will fall at the same rate, which probably isn't the best idea, to be honest. But anyway. Or, wait a second, I can make it so that... they can only move in the direction they're facing. Because I still have that rotation attribute. The rotation, this might be a bad idea, but oh well. We'll make this a quaternion. We'll do a rotate vector. Rotate vector. There we go. And this is like Y. Yeah, that's Y. So, and then I can use the humble dot product because that is just the best node to ever exist. The dot product, learn how it works, because it's, in my head, the way I think about it now is a distance along axis node. Along the velocity, I'll see how far along the velocity is around the, in this case, the y-axis of the rotation. So it'll tell me how far that's going, and then I can scale this so that it'll only keep that component of it, if I am correct. Why are they all facing backwards? Oh, right, their initial... They can't move backwards because the... Yeah. They straight up cannot move backwards. Such fun. Because they can only move the direction they're facing. So I'll need to give them an initial rotation. Let's go over to here. Oh, actually, no. I'll go to the spawn area. I really need to put these into node groups. But here, for the initialization, go and set so that the Z is 180 so that they are facing that direction. And we can see now they can actually move that way. So for some reason, I have a feeling that maybe I chose the wrong axis. So they should be moving... Or wait, I could have just used a vector projection here. That would have worked the same. Because internally, projection uses a dot product. Oh, and that seems to work just fine. Oh, wait. No, I screwed up the math a little bit. Oh, did I need to normalize and then scale it? Oh, maybe that's why it's screwed up. That could be a reason. So here, they will just straight up keep moving the way they're moving. And never really change. Beautiful, isn't it? So now I guess they're just running off of... Yeah, no. Right now they're just running on their rotation rather than that. So I guess I could just... Oh, should I just make it so that they use their rotation and then they try to rotate towards this guy right here, and then that'll determine where they're going. That might actually be a good idea. Just make it all rotation based instead of whatever the velocity based. Let's give it a go. Even if it's not a good idea, it would be cool to try it out. Here, I'll use an align rotation to vector. The chances of this working is low, but not zero, so we'll give it a try. Auto, so in this case, they will now always face the empty. We can see. But if we set it to be just a little bit, they will now start to... Oh, yeah, no, now they take time to rotate. 0, 1, let's send it again. But yeah, as we can see now, they actually have to rotate to go to there. So maybe that's the way to do it. Like, could I do that with the velocity? Yes. But should I? Eh. Oh, that's actually beautiful. As I say, as a horde of zombies are doing that. Oh, also, one thing I forgot. I need to randomize the object info, the texture. Now this is pretty simple. We'll just use a vector math, add with a nice little multiply, put it into there, set to be 1000. Control A, Control H. So now we will see. Okay, the texture is not freaking out whenever new ones get added, but they will freak out if new ones get deleted. Which is why, for the little particle system tip here, we need to give each particle a unique ID when they're initialized. So in this case, I'll go and set the ID value, which should just be that, or just use the set ID node. I'll do this just so that my eyes don't glaze over with so many store named attribute nodes. And with this, we're going to make this a hash value node. So here, hash val. Oh wait, but with the substeps. Dang it. The substeps will make it so that this does not work as intended. Although, it could make it so that the domain size will guarantee... That might actually be a good idea. So I'll add both the index and that just to guarantee that it is different every single time. We plug that into there, and we should see that the randomization feels a bit more random because it is. Or wait. I need to make sure it's not actually changing, which it shouldn't. It should be guaranteed that all those are different now. Also, let me turn on motion blur. Does that look? The ID value should also make the motion blur a bit more solid. But that is absolutely that is terrifying with the all that. Wow, that is. Oh, that is actually terrifying. I need to turn that down. That's a bit more reasonable. also, let me save this because we're actually cooking here. Let's add in the bloom. Just leave the defaults on. Let's go over to here and turn the compositing to be always. Actually, for this part here, do that. What does it look? I think having a checker texture would be good. And also we need to make it so that they don't fly nearly as much. And I should make it so that the collision is an ellipse, but spherical collisions, that's all we're gonna do for now. Like, it does look really cool how they're all doing that, but can't say I'm the happiest with that. So maybe, let me think about this. How do I make it so that we actually don't really need this guy anymore? Because, yeah, no, we actually don't need that. No, wait, we do need that because the velocity is now doing a cyclic thing. So I guess, I need to make a decision here. Do I make it so that the rotation is driven by the velocity, or the velocity is driven by the rotation? Let's see. Because velocity-based makes more sense. I could, wait, I could just make it so that this rotates. I do like how it actually takes time for it to rotate to the new orientation, rather than it just instantly doing that. So, yeah, I guess I need to make a decision about that. And also, I would need to make a decision about the... Yeah, no, this... Maybe I mix... Maybe I affect the hit normal, or at least the visual part, differently, and we just run the rotation based off this directly. So if I'm annoyed with how fast the creatures like rotate to face a wall or something like that, I just change that. And if I'm annoyed with how the movement happens, I just change the velocity. I think that is a sound way to make all that go. I will read the chat, sorry everyone, for ignoring you once again. Let's see, what's your hardware configuration? I have an Intel i5, whatever generation processor, and a RTX 3060 Ti, I believe. Is it possible to offset the animation for each character? Unfortunately, no. We do not have that technology. Don't have the technology. We're projecting and normalizing. So in this case, I'm going to... The rotation is driven by velocity. Let's look. Now that's funny. That's really funny. So in this case, I'm going to make it... Well, we have the main velocity stuff doing stuff here. I'm going to make it so that the velocity rotation can only happen a little bit at a... Actually, wait. Here, let's... Yeah, no, I'm not happy with that. Take that out, take that out. We're simplifying the logic here. So in this case... Oh no, wait, but... If I add in proper velocity changing with this part here, then they'll start freaking out. Well, now let's just run this as is, and we'll figure that part out. So we'll have the rotation here, and use an align rotation to vector node here, and then we'll try to align it with this one. Let's be Y. The pivot will be the Z axis. should be the normal, or no, let's keep it on auto. And then we will rotate a vector based on that, which in this case, it'll be the Y, and then we feed that back into there. I'm not sure if this is a good idea. Maybe it is? Are we getting the functionality? No. Not quite. We have that, it's doing that. Maybe we just, you know, set the velocity. Okay, well, we can see that that part is now working. It is taking time for the... Whoa. Okay, well, looks like I found my answer. -2. So here they will... go down. This is setting the velocity every frame. Just double checking. Oh wait, is this wrong? Oh, I would be very upset if this is wrong. Because if we set the velocity... Oh yeah, no, that is... No, that's correct. Never mind. Need to set the damping to 0. Dang, Eevee Next is quite noisy. Not loving the way it's looking right now. Do I just need to make it so that it's a bit more... It'll take longer for them to do the rotation. Well, that is, again, rather terrifying. Maybe I should spawn them in with random rotations. Yeah, that could be a good idea. Let's do a random value node. We'll go and do... yeah, that and that. Use the frame into there. Yep, that's working. That is working. Should make a nice little shader for the origin of all this. But I think the effect, we're at 47 minutes, but the effect is close to done. I just need to fine tune it so that it looks good like it was looking before. And we don't need the normalization because it just goes straight into there. Don't need to worry about that part. So in this case, the velocity is straight up. Like that. Being set every single frame. That's could be better, but it's not bad. Okay, let's go and make a nice little shader here. I'll need emission, transparent, mix those two. I'll need to get the UV map, and I'll go and move the UV, so that's right there. Scale to 2, yeah, know that. Just to simplify the process. Let's go and get the length. And I'll go and use a color ramp into my LG light fall off node, because that makes all of the gradients nice and crisp. Which reminds me, I need to be using Filmic instead of AGX because it makes the colors a little bit better. A little bit more... I know people say, oh, don't use Filmic because it washes or it clamps the colors and all that. And while I agree that it does, I like the look. If you do it right. So please forgive my sins when it comes to using Filmic. Okay, nope, we don't need multiply there, we need multiply there. There we go. And now I just need to use some noise to offset the length, and everything should be golden. Everything's gonna be golden. Let's be like 1. Then, yeah, I should have the middle be completely black. So here, we'll have this be... Yeah, no, that should be for the strength. No, but it can't be for the strength because of reasons. I don't want to make it 2 layers. We'll reduce that and then just turn up that part of the noise so that we can have it like that. Yay! And then, yeah, we can just do a little bit more of that. Keep it like that. Set it to ease. There we go. Now we're cooking. And then maybe some animation. Oh, it's already 3D. Okay. And also, you can see that since I'm using the Vulkan backend for Eevee Next, I can work as fast as I would in Blender 4.1. I am a big fan of Eevee in Blender 4.5. I feel like I can work as fast as I normally do. So 4.5 will most likely be my daily driver from now on, when it comes out in less than a week. Though we can see that the denoising is still having a whale of a time. So we turn off temporal reprojection. There's still ways to go, but it has gotten a lot better. Actually, wait a minute. Do I make it so that the collision radius is 0? At least for the surface? No. It needs to be. The creatures, I need to just lower the armatures down so that they're actually on the surface. There we go. The noise. And that problem. That's why I need to go and mix the normal on its own. This will be velocity. There we go. This will be new particles. Go. Like all these frames should probably be individual node groups. But it's fine, you know? It's probably fine. And I should reduce the... no, that's fine. Set this to 30 and 30. That's not... I just want it to be a round number. Let's get the camera all nice and set up and make the resolution 1024 by 1024. I still want them to have a bit more, like, them crawling over each other. It feels like negative 0.1. There we go. You only get that when that's happening. And then they just spin. And I should also, like with the relax points node, should go and get the hit normal from here and then store it. Or at least capture it so that it can be exported. Because having that information could be useful when they're climbing over each other. Yeah. Yeah. Okay. So what I'm going to do is change a little bit of this. So the hit normal, I'll make this the rotation normal. So I'll mix between the current hit normal and the rotation normal right here, and I should normalize the output. Because, well, I could just align rotation to vector. Yeah, I should just do that, shouldn't I? But we'll just take the... Yeah, no, that's a smarter way of doing it. Or... Align... Oh. Align rotation to vector. We have the rotation, we have the vector. It'll be the z-axis, and we... Just do that. I don't know. So if I turn up the gravity again, having two of them feels a bit wrong, but yeah. And we're okay, we're still under an hour. Okay, not bad, not bad for a little effect like this. Let's turn up the gravity. So they still fall like that, but oh nope, they're still freaking out a bit. Let's set this to be 0.01 because I want the oh no. No, that is a velocity problem. Or no, wait. Why are they freaking out? Am I really going to change this again so that it's all rotation based instead of velocity? Oh, that... I might actually try that version of it again. Because this does not seem to be what I wanted. It's close, but not quite. Treating these like characters, actors in a scene rather than just points with velocity. Then driving the actual movement of them based off of their rotation instead. Because again, it's like, oh, which one comes first? The chicken or the egg, I guess. And also, let's move this back over to here. Yeah, and then, yeah, I could use the hit normal to do most of that. Okay, I'm gonna save this and then try the, oh, everything is just rotation based again. Here, it's just gonna be this. And we'll have the set part there. If you're wondering why I'm not just setting the velocity, it's because delta time, we still want to use delta time in here. So we should be using the node group. Very convenient node groups. Let's see. Let me read the chat again. It'll be interesting if there's functionality to change the gravity or pull force depending on the Euler direction that the armature is facing relative to the world. Yeah, that's kind of what I'm trying now. Because right now, all these are just headed in their rotation orientation and not doing anything else. But we can see it actually looks pretty good. Like, mixing the animation with all that because they're moving at almost the speed they should be. I think 4 meters per second is the right one. Like, if we look at this, we should see that they're, yeah, it's pretty much guaranteed to look right. No foot sliding and all that. Now, if we were to set this to be, like, 1... Or let's do 0.75 meters per second. Let's just go and try this out with the old one there. We can see that. Dang, that's slow. And they're sliding around because of the self-collisions and all that. Dang, that is way too slow. And then we can just go to the... I need to rename that. Let's set that to be 4. So 4 is just about right, but we could do a little bit more. Okay. Anyway, let's go and affect the rotation again. Take that part out. We don't need to... I might put the gravity in there, but we don't really need that currently. So again, this is going for a rotation first mindset. That, and then also the hit normal. So yeah, we'll have the velocity, but we'll also affect it by the rotation here. So I do, again, feel guilty with how... Doing that. Make it so that this is locked to the Z. So now we can see, yep, they are facing that direction. They're moving. And it's not auto, so if I were to do this, it will try to, like, aim both up, down, and side to side with all that. Let's put this a little bit closer. And since gravity is not an issue, see that happens. And the normal, the hit normal is based off of this collision, not this collision. Again, there shouldn't really be too much of a difference with those two, but I don't store the normal for that. But I will, so we'll do this as of collision normal. Go, so we can store that, and then we'll see how crazy this can get. So, of collision normal. So here we can see, if we turn it down a lot so that's just more cohesive, this will face the nearest neighbor, then do that. I guess the thing is, I'll probably need to make them switch between, like, going towards your nearest neighbor, or orienting, making the floor your nearest neighbor, or the floor based on if you're colliding with your nearest neighbor or the floor. But I think the floor is the way to go. So let's set this to 0.025. Again, not using delta time for that, even though I should, because substeps are good. And now we just have a ton of zombies going through the air. Do all that. I should really change the shader a bit more. But the main thing is we can see that's working pretty well. The velocity here, I can also make it so that it completely override that. So yeah, let's add in gravity once more to hopefully make it so that they fall down to the ground. Okay. Here, they can actually still do that. Let me go and change the normal, their up direction. But I still don't really like that they're not, like, climbing over each other anymore, because that worked so well. Okay, let's add in more variation to the shader. Here, I'm just going to make it so that the random value, we'll put this into a white noise texture so that we can get a, actually no, we don't need a different hash. Well, this will use a map range, set this to be either 5 or 50. There we go, so now we have, actually no, we need to put this into a white noise value. Just to kind of like rehash it. No, it feels like they're just not moving fast enough. Let's see. Oh, did I already read this? Is this recreating that scene from The Last of Us? No. I mean, it could. I mean, zombies are zombies. But I saw this kind of effect in another movie, and I'm just like, oh, I can do that. Let me do it. Let me make it. Maybe I should make it so that if they collided previous frame, then they don't have the gravity, or if they are colliding with their friend, can actually pile up. And I should make the gravity force the hit normal. So let's go over to here. And instead of that, we're going to use the hit normal. Which for the first scale, let's see, similar to those creatures from Avengers. Well, I think Horde of Faceless Zombies is a pretty common trope. Here they can climb on any surface that's available. Can you show us what you worked on for the Sonic movie? That's cool, by the way, congrats. I'll save that for another time. But all I want to say right now is that, well, if you're watching the movie, within the first 30 seconds, you're seeing a good amount of my work. And throughout the, like, there's probably 30 minutes of technically my stuff on screen. Maybe. Actually, yeah, probably. Probably. I haven't actually... I should actually compile that. I actually haven't. Anyway. I think... maybe with a bit more... A bit more work. I think I can make this look really, really good. I just want to get some of the jank out. It's amazing, I saw it looked really good. Hey, I'm glad. And I also have to say that, you know, I didn't work on everything. No one company works on every shot in a movie, usually. So just keep that in mind. Don't want to oversell my contribution. But it was the best work I've ever done. Let's see. Okay, we're at 1 hour and 7 minutes, so I should wrap up the stream. We have the effect, and I think it's pretty solid. Again, working with the rotations instead of it all being velocity-based is a little bit easier for people to understand, I think. So if I were to just rotate the... Hey, rotation, come on, buddy. Instead of it to be local, we can make it so that they spin along their z-axis per frame. Which, again, because with this, we have substeps going, they will now constantly go in circles. Yeah, we can see that the hit normal, because we're interpolating it, they don't just immediately switch from being up and then to the side. Which we can see here, that could be a little bit iffy, so it's just like that. Again, delta time lerp should be used for all these, but because I'm lazy, we're not... Oh my god, that is terrifying. Let's go and turn that off for now. But what if I made it so that they had to spin on their x-axis? Oh, unexpected. 1 and 0. I thought they would like spin up or down, but yeah, no. Let's chop that out for now. Yeah, I think this is pretty solid. Actor rotation. There we go. Oh, my mic's pretty low. Hopefully my keyboard clicks weren't too loud. I need to get a microphone that just ignores all keyboard clicks, or just finally get that add-on for Voicemeeter to do that, but that, as I saw, was a bit of a pain, so I don't want to do it right now. But yeah, it seems to be pretty solid for a nice little effect. Again, ideally, like, if you're in the future and it's like, oh, wait, I want to do this, it would be, oh, we have a very solid particle system where you could just do, like, Boyd-like, stuff, but we're not there quite yet, so... We're close, we're getting there, but it's not quite there yet. And also, the self-collisions do not affect the velocity. Which, that is probably why they're not clumping. So, Yeah, no, that's the problem, isn't it? These collisions are not affecting the velocity. Though, they should. I guess I could just do a vector rejection on the velocity. I know I'm editing, just some stuff to get a bit more control. So I need to just to do a vector rejection, you just project this along an axis, and then you subtract from the original velocity, or the original vector. So a projection, subtract that, and it becomes a rejection. In this case, it should... Oh, that sucks. I think it's because they keep hitting their neighbors so often. Yeah, I was worried about that. Alright, let's ignore that. Could do... Oh, wait, maybe that's what I should do. Since this is, like... Yeah, no. Since there are iterations here, I should go and stack, like, the iterations over time, and then the output is what I would do that on, but let's ignore that for now. It's fine. I could just go and make it so that I recalculate the velocity in post. Yeah. But for now, one layer of the particles is it's good for now. Let's see. I haven't watched the Sonic movie. Would you recommend it? Unbiased opinion. I would 100% recommend the Sonic 3 movie. I don't think you need to watch the previous two to really understand what's going on. It's pretty simple when it comes to that. But it's legitimately a good movie. From the first time I saw the story of it, I was like, oh wow, they did that. Huh. I'm surprised. It's legitimately a really good movie. Now, Knuckles, on the other hand, well, I did technically work on Knuckles as well. But yeah, Sonic 3, I would recommend it. It's good. It's absolute cinema. Though people did enjoy Knuckles. Let's see, give them a random vertex color to see what's happening. I tried your free GeoNodes asset pack. The SDF node was a nice introduction to the concept. Now I've learned a lot about it. Hey, that's nice. Yeah, sign distance fields, even though it's like, in my case, like sign distance fields, I'm not using it in the typical like, oh, you have a volume that's an SDF. Just regular, like, oh, you have a distance and it's signed depending on whether you're outside or inside the mesh. It works. Like, it works very nicely with collisions. It simplifies the process a ton. It's like geometry proximity, but you get the distance whether you're inside or outside the mesh, and you get the hit normal so that you can move the point outside the mesh. Because collisions, for the longest time when I was a youngling, when it came to, like, simulations and stuff like that, collisions were a big pain. And they still are, don't get me wrong, but it's mainly just because of geometry nodes has some hangups when it comes to that still. We're still lacking some technology that is in other parts of Blender, which maybe I can get those ported for 5.0, but that would be an undertaking. Where was I going with that? But for basic collisions, you know, you just need, or basically for all collisions, but the amount of collision points is different, yada yada, you just need a distance to move and a normal. So you need to know what direction you need to move in to resolve the collision, and how far to do it. So that's what the SDF nodes, like in this case, do. It gives you the distance, and then it gives you the normal, and then this interprets, oh, here's the distance. Oh, if it's negative, then we need to move this way to get out of it. So yeah. And I don't need to store this part right now, but it's fine. Okay, so I think that's pretty much everything for now. The effect works. It works well. I could vary the, Oh yeah, no, that's something I should do. I could randomize the speed for these a little bit, like a nice range without it feeling like janky because of you know, the animation speeds and all that. So some of them will be faster, some of them will be slower. I can give some of them a faster rotation, some of them a slower rotation. As we can see, yeah, it does its job. You can see here that they're... Yep. That part's working. They don't have actual pathfinding, which for that you would actually need a grid to tell them, oh, which way is being obstructed, which one isn't. But, you know, in this case, it's fine. Here we can see they're desperately trying to go up, but they just can't. They're trying their best. Okay. I think that's everything for today. Thank you all for watching. I'll read the chat again just to make sure I didn't miss anything. I should really put the spawn rate on the outside, but nah, it's fine. I need to stop worrying about that. Hit normal determines that, and I could still mix in some gravity. And I could also make it so that this just switches. So here, we'll do, yeah, we'll use a wrapped node. In this case, it'll be like that. We'll use a greater than, an equal to node. In this case, it'll flip it on or off, so every other frame it'll spawn 1. This will make it so that every 5 frames they'll spawn 2 because of substeps and all that. This part just should be outside the substeps. Here we just have a few of the zombies moving around. And if I really wanted to give myself some pain and suffering, this will make it so that there are 20 spawning in every single frame. And with this, yeah, no, I really need to look into the functionality of making them, like, actually layered. Actually, let's move the this part up here a bit more so that they... Okay, well, oh, we are getting some of that functionality since some of them spawn up here. Oh my, whoa. That's uncomfortable. That is... Wow. I'm equal parts impressed and horrified by my creations. Though it still looks like some of them are walking on air. Which, how? Oh, wait, is the collision surface? No, that's why. I was doing that because the collision surface was not set to the right, thing. Although... No, that's still wrong. I would have to make the simulation global space for it to all properly work, but currently it's not. I could add in another variant so that we get more... So it looks like they're less synced up. I can do that off stream. Let's go over to these guys, turn the viewport display, make them a little bit darker so that we can see where they're moving a little bit easier. Yeah, if you ever want a ton of zombies moving in a horde, in a swarm, then you can do that now. So fun. Are the animations all in sync, or can you offset them? In this case, they're not in sync. There are 3 variations here, all with different timings. So if I were to hide this... What is this plane? Oh, that's part of the... Yeah. Here we can see that they're all, like, different phases of the animation. So, yeah, none of them should be super synced up. Though, yeah, it's... I do need to add in more maybe, I think 4 would be enough because this is like a 10-frame animation. Oh, wait, I can also change the scale of these a little bit. I forgot. Yeah, let's add another random value set to be float, just so that we can have a little bit of size variation as well. Change that. I could make it so that the radius affects that. Could make it so that there are small ones and big ones, but right now, all of them having the same, Actually, no, that's something I should do. So here, the radius is affecting that. So yeah, let's make this the radius. There we go, plug that into there. Radius will be that, and since it's too small, we'll multiply it so that visually it looks right. And then we'll affect the... Okay, that's good. We'll change the radius so that we get a different look. Here, this will be a random value. Actually, yeah, here, because substeps are still creating a few problems here, we're going to make it so that the seeds are all driven by this. There we go, that's better. So now if the point count changes, which it will every single time there's an update, we'll go and do that. So this is our random value. I know this is becoming janky, but here we'll set the radius to be like, or no, we'll use a random boolean and then use a switch node so that we'll have lots of them that are regular size and then a few that are abnormally large. So here will be a 0.1, a 10% chance that we'll get a big boy. Yep. Although the collisions do not seem to be doing their job. Yeah, no, the size variation is a little bit much right here. But we can see that the big ones are literally stepping over all the smaller ones. Because there's no mass. So if I make a more robust particle system, the little ones would not be able to move the big ones. And then all this would work properly. So let's set this to just be a float. And we'll set this so that there's a little bit of variation. And that should be good. Back a little bit. Then for here, let's move this down to like maybe 0.2. You soften the self-collision so that there's, you know, just a bit more stuff happening. And right there. A bit more going on, bit more variation. The swarm looks a little bit better. Because not all zombies are the same size. But yeah. I think this is almost the final form of it. There are some motion blur. Yep. Zoom in on that guy. Now that guy's having problems. Now why? Is that just because the velocity is affecting the rotation a bit too much? Yeah, it's because of that, which is annoying. It gets stuck on the low ledge. So I could cheaply just put in a bevel modifier to soften that up a bit. Be like maybe 0.25. Just so that they get caught on it a little bit less. Oh, look at them. They're having such a fun time. Okay. So, for the 5th time today, thank you all for watching. Let me read the chat once more, because I keep delaying the end of the stream. But this project turned out much better than I expected. Maybe a little bit cleanup. Let's go and delete the... Oh, I'll keep the 0.75 meters per second. So this will be... let's see. Body for ms, meters per second. And this will be... Nope. And this will be 0.75. Go, and this will be 0.75 Changing the naming so that's a little bit better. Actors. Yeah, that's what I'll call them. Actors. Actors. There we go. There we go. I should probably tone down the emission to make them a bit more recognizable at a glance. That's good. That's good. One more variation in the animation and it should be imperceptible. Yep. Okay. One more read of the chat. That's what I need to do. Okay. Let's see. Hey man, you're a GeoNodes legend. I saw you doing a Touch Designer GLSL video, and I was very psyched to see you get into that. When are we getting more Touch Designer videos? Basically when I feel like it. Although, Touch Designer is much less popular with posts and live streams just because, again, many people use Blender in my community because that's what I curated, and basically no one uses Touch Designer. So I think I'll mainly stick to Blender, at least here, but I do really like Touch Designer. Even though Blender is more convenient for a lot, the real-time aspect with Touch Designer, like, it's the industry standard for music visualizations and stuff like that, real-time visualizations for all that, for a reason, and I do quite like it. Yep. The honeymoon clip is fantastic. I would love a tutorial. Actually, we can do that right now. Yeah, so let me just go over and open that file. Let's see. I'll open up the... Yes, here we go. So I do have to warn you, it can be a little bit complex because it's... I can simplify it. I just made this within an hour, so I have not made it pretty. But here's the honeymoon. So we can see it's just... Yeah, this is the main thing. It's just noise. Actually, yeah, let me break it down here. So this is the main thing. It's just noise right here. I do fraction to get banding. And then I ping pong that, add in some noise, you know, to get some variations. Then I use a map range to constrain it, use the LG light fall off to make it look super nice and crisp. Put that into the alpha, have some of that, and then I layer it so that we have multiple layers of it going, which I use the object color to go and fade it out as much as I want. Here, I make it really bright with the object color, or I tone it down, just for customization. Again, this was done very fast. But that's basically it. It's just, you pick a cool color to make it go with, and yeah, it's just noise texture with banding. That's the entire effect. That's super complex, again, made in less than an hour. And then I added this part here just for some displacement. Like, I wanted to make it a bit more fancy, but I just made it more complex, don't worry about it. But yeah, it's just noise with banding, and then with some compositor stuff to make it look better. I added in, this is fake depth of field, because the default depth of field likes to clamp the parts outside of there. So the depth of field here is completely fake, but it just looks better. And then I just add in some bloom, and then some streaks to make it look all nice and sparkly. So that's, yeah, that's that. Okay, would it be possible to add a guide curves for the path follow? Oh, that's a great idea. Why didn't I think of that? Yes, that should be possible. That should be very, very possible. They're like those ants that build bridges. Oh yeah, I could do that. Yeah. Okay. Hey, I'm trying GeoNodes. Do you know how to slow down geometry node simulations? That would be by slowing down what you're doing. Like, everything happens per frame. You can't change that unless you use substeps, but in that case it would make it faster. You just need to slow down, like, how far you're moving an object per frame, and that's that. You just need to slow down what you're doing. You can't slow down, like, how often simulation nodes evaluate. So it'll always be one frame every frame. Yep. You introduced me to Touch Designer, and I have had some fun messing around, and the GPU performance is great. Yes, I enjoy being able to use millions of particles, because in Blender, you just can't do that. But yeah, thank you all for watching. I hope you all enjoyed, and I will see you next time. Have a good one.